Thanks so much, everyone, for coming. It's really great to see so many faces in our brand new office. It's been a long time since I've done one of these things in person, so fingers crossed we're sharing the right screen and the microphone's not muted. Sorry for the joke. I just been told a housekeeping rule that the exits are that way and then that way. So Wei Ann and I are going to talk to you about what we think you need to know before you grow. So based on our experiences of scaling the estimating product of Tractable, which is Tractable's fastest growing product, we've kind of come up with 3 lessons that we've learned. And when we talk about scalability here, we're really talking about product scalability and how you grow your customer base. So before we start, I always like to start off with a fact. So 40% of European AI startups do not use AI as part of their business. Tractable's not one of those startups. Our vision is to positively impact industry, people and planet with AI. So we have ML-centric solutions that target real-life problems. So I'm Georgina Steele. I'm a product software engineer at Tractable. And before starting at Tractable, I worked in the fast-paced world of Formula One as a structural design engineer at McLaren. And then I decided to switch from fast cars to crashed cars and joined Tractable. I joined into the customer engineering team where I was focused on integrating our solutions with customers' systems and workflows. And now I'm in the product team, the estimating team with Wei Ann, where I'm focused on scaling our products.
And I'm Wei Ann. Nice to meet everyone. I'm also a software engineer. I have also been at Glastonbury for the past week, so I'm sorry that I sound like this. Bear with me. But yeah, so my background is actually in physics. I spent my master's looking for dark matter candidates at the Large Hadron Collider. And what that means is that I actually just sat in a room and made a bunch of graphs. It's not actually that exciting. But I started my career in tech in Accenture, which is like a consulting company. And we built proof of concepts around emerging tech for our clients. And since I joined Tractable, I work in the same team as Georgie, but I work closer with the machine learning researchers, helping us build out what our AI can do, basically. Yeah, so like Georgie mentioned just now, we're gonna talk to you about how our product has scaled and how the tech and the teams have scaled with it. But before we jump into it, I wanna show you a bit about the product itself. So you got this fancy video here. So the product is called AI Estimating. It serves users, maybe like some of you here, who have gotten into car accidents. And if you've ever been in a car accident, it's a very, very stressful process. And all you want to do is get back to your daily lives. So just by uploading a few pictures and a few information about the accident, our visual, computer vision-based AI is able to assess the amount of damage in the vehicle and predict how much it would cost to repair it. We give all this information to insurers, and it helps them basically make a decision on the spot on what you should do with your car, whether it's total loss, forget about it, just go and get a new car, or whether you should take out your insurance policy and pay it back. So yeah, on the horizon, we have cool features like straight-through processing, which will let car owners directly book in repairs with the body shops. So just a little bit of background. It took us a while to get here though. In November 2014, Tractable was founded, and it was kind of founded on the idea that neural networks and deep learning had reached a cusp of becoming the industry standard. It was pretty good timing because 3 months later, this was validated industry-wide when AI first beat human-level performance at image classification. Since then, we've been spending our time building out products that help to achieve this mission of accelerating vehicle accident recovery. And last year, we expanded into new verticals. So now we also do property damage assessments. So like in Japan, where there are yearly, unfortunately, like a lot of yearly typhoons, being able to assess damage on that and get insurance payouts too. And last June, we became the world's first computer vision unicorn when we were valued at $1 billion. Which brings us to today, where our products are used by over 35 companies around the world. So what we look like today with this fancy new office, we didn't really look like this, like back in this point. Back then, us as a company, we were quite obsessed with, getting customers. We wanted to make a product that would actually be used by people in the insurance industry, But that kind of customer obsession that helped us find this like market fit started to kind of hold us back somewhere along this journey, and we had to pivot to a more product mindset. And yeah, I'm gonna let Georgie talk you through some of that.
Cool. Thanks, Brian. So as you can see, we've grown like really significantly over the last year and a half. And as a result, we've kind of identified 3 key points which really enabled that rapid growth. The first of that is simplicity is queen. And what I mean by that is simple solutions allow for greater scalability. So when we first started designing estimating, it looks a bit like this. We thought that every estimate would go through this very specific journey. As we then started talking to more and more customers, we found out that everyone's journey is very different, and thus this was producing a lot of rigidity in our system and meant that we weren't very extensible. So the issues that we identified was this very rigid flow, difficult customer onboardings. So if a customer came along and their flow wasn't quite the same as this very specific one, it meant that we had to add workarounds in the code, and the code base became very messy. And as a result, we had to have a lot of unnecessary manual interventions. So this is an example. So say we had customer A who we designed our estimating system around. Someone crashes their car, they get very angry, they call their insurer, take pictures. We produce this estimate, and then we can repair the car, and the person's very happy and they jump for joy. And that's their journey. And then we had customer B come along, who seemingly has a very similar kind of subsection of this journey. But the issue that we found was, because we've designed around this one in particular, it's very hard for us to onboard customer B, and we had to add a lot of code. So we kind of thought, wouldn't it be better if, when we're onboarding these customers, we don't have to add any code? And how could we do this? Maybe like we'd do a bunch of calls and that would execute each of the steps in series, or even better, a bunch of instructions sent into our system, and each of these steps are executed in series. So that's what we have now, where each of the steps have become asynchronous events that can be executed in almost any order. And the customer just passes in this set of instructions, so they're able to pick and choose and kind of build like Lego blocks what their product journey should look like. So the benefits of this is you can easily add new journeys. All you have to do is change the instructions that you pass in. Equally, it's really easy to replay a journey because we have this set of instructions, which means that it's very easy for us engineers to do good debugging. And by separating this execution versus orchestration responsibilities, so the executing now done by our system and the orchestration by the instructions passed in, means that our product code base is a lot more extensible. So going back to the example earlier, we now have customer A who's built this workflow with their instructions, and each of the events can be executed in almost any order, and we do it based on the instructions that they give us. And then customer B comes along and tells us the instructions, and we can then execute the events in the order that they want as well. It means it's really easy, not much code has to be written, and it's a lot better. So the lesson was, don't assume so much rigidity up front. So designing something simple that doesn't contain a lot of customer logic. This doesn't mean designing something for the future that you don't necessarily know. It simply means go back to basics, and when you start, don't design it with something that has so much customer logic in your code base. And then, as a result, it has flexibility at its core, a bit like this man doing the splits. And by separating that responsibility of orchestration, we were really able to bring this about. So our second thought process as we were growing was, what about customer needs versus product needs, and what are the differences between them? Before I get into that, just want to define what client configuration is. So our product is built for many different users, and they're all businesses. So we have one product for many people, and as a result, we have to set client configuration for each of the businesses. So this includes things like branding, having their logo, language, country-specific machine learning models, so anything that's specific to the client. So our question that we got here was, should the product team only care about product? We have this conflict where on the one hand we get requests to update this client configuration, and that slows down our product development. But then on the other side we have our focus on product development, which is slowing down our customer responsiveness. Of course, we're really accelerating our growth as a company, and we want to be able to create POCs and demos in order to win new customers. But equally, we need to make sure that our product is growing and changing for our existing customers. So the reason we had this conflict was because client configuration was stored in the product repo. So you would assume that as a result, the product team is the owner of this. But we have the customer engineering team. They're responsible for onboarding customers, and they're responsible for changing client configuration. So surely it makes sense for them to own our client configuration. So the solution was to remove this client-specific configuration from our repo. We did this by building a client configuration service. So we wanted to create something that was able to be used by people without in-depth knowledge of our product. And so the requirements were storage, versioning, schema validation, easy-to-use interface for these non-technical and non-context-heavy users, and equally, we need to make these changes fast. When a client requests something, we want to turn it around really quickly. Of course, though, we're growing fast, we're onboarding customers really quickly, we want this and we want it now. So were there any existing tools that we could leverage? We looked at Launch Darkly, Unleash, Kubernetes config map, and AWS app config. But none of these really fully satisfied our requirements. So then we thought about, can we build this internally? But of course, building something internally has its own challenges, and it's not that fast, and it might not be as stable because we have to build it quickly. So we decided to go for the combination of AWS app config and in-house built UI. So AWS app config is really useful because it has that storage and that versioning. You can also do schema validation by attaching a validation lambda to each app config profile. And then equally, they have canary deployments, so you can leverage that. And as we're growing fast, we're onboarding more customers. We want to minimize the impact of faulty deployments. So we built this UI, which is up here. And in that UI, you can adjust the client configuration, and it will then show you an example of what that will look like in our product.
Yeah, it was built during, we have a hackathon every quarter, and I think one of the teams built this in 2 days, so it was pretty cool.
So cool. And then once someone changes something in the UI, it will then create a GitHub pull request, and then we leverage GitHub Actions, so GitHub workflows, apologies. And as soon as that PR is approved, it's merged and straight away deployed to AWS app config. Our product will then fetch that configuration from AWS app config, and that change will be reflected. So our lesson was, as you start to scale your customer code base, you need to start separating out customer needs from product needs. So separating out client configuration from product will increase responsiveness, and thus the customer teams will be able to manage the customer configuration, and the product teams can focus on building the product. So it's like separating an egg from a white egg.
Love your analogies, Georgie. So yeah, thanks so much, Georgie, for that. So this next section, we're going to be moving a bit from the tech solutions that we had to adapt for our growing product to how our teams had to be reshaped as well. Just going to give a warning, I am not an expert in management or organizational theories. What I am is a software engineer, and like many of you here, I think collaboration and communication in our teams is super, super important to just our, how well we work together. So I know what it feels like how frustrating and disruptive it can be when there's a structural flaw, in your teams that's not letting you do your best work. So I'm going to be speaking from that perspective. Yeah. growing pains. When I first joined, our team was quite small. I think there were like 4 researchers and 3 engineers or something. And it really felt like all of us were subject matter experts. So I'm talking about like, we work in a very specialized industry, so having to understand all these crazy things about insurance. I now know way more about a car, like what the inside of a car looks like than I ever thought. But also having to get like understand how our CI/CD pipelines work, or like, so a lot of implied knowledge. Everyone knew how to maintain and work on our systems. And this was really cool because it gave you a lot of autonomy. Every decision that we made felt like fully driven by context. But what happened was that as our product grew, what also grew was the sheer size of the software and the amount of context that we all had to hold in. And our team also grew. I think we've like quadrupled in the last, year and a half or 2 years. And what it meant was that you had this big group of people, every single person having to know every part of our system with the way that we were working. And to be honest, on the ground, what that felt like was like a complete overload of responsibility. I had no idea who to go to for issues and whether it was even my responsibility to do some of these things. So we knew that something had to change because we were just not operating as efficiently as we used to. And when we thought about a team restructure, we wanted to obey 2 constraints. First one is team cognitive load. So quote is about to come out, so be ready. This concept of cognitive load was introduced by an educational psychologist called John Sewell. And he defined it as the total amount of mental effort being used in working memory. This concept is, I think it was mostly used for like learning and education and how you can structure that for the best. But it's also very, very useful in software delivery teams, mostly when trying to figure out how to determine your team size and your team boundaries. So TLDR, a team has a limited cognitive capacity and it needs to be optimized for value. And I really hate using the word value because it sounds like business value, that's all I have to do. But I mean, as engineers, we care about our craft, we care about doing meaningful work, and we need the space and space to do that. So as a team, what we were experiencing, because we just hadn't managed this cognitive load as it grew, was that we were completely stretched to cover excessive responsibilities in this huge domain. There was a lot of context switching. It also didn't feel like you could build a mastery of a certain thing because you had no ownership of a specific domain. So that was one of the things that we wanted to fix. The second one is Conway's law. Can I have a show of hands here who's heard of this concept? Got a few. Nice. I like it. But as a reiteration or introduction, Conway's law, again, quote coming, says that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. What I take from this is that if you're working on a product, the way that the people who are working on this product communicate should mimic the way that the code that supports this product communicates. This is a really nice diagram from learn stuff about how the systems, your team should mimic the systems. One thing that has been quite big in the past few years is that people have taken Conway's law and kind of flipped it on its head, and they call it the inverse Conway maneuver. And it's more that you should be structuring your teams around your applications. And I think when we thought about this, we really wanted to make sure that we had a complete and independent decision-making ability within each team. And it was really cool to see that we could start treating these communication interfaces between teams like the interfaces of a service API. Those are the 2 constraints that we were looking at. Took all that and we borrowed some concepts from domain-driven design to come up with this concept of domain-driven teams. So I'm not gonna bore you with the details because you don't work in this company, you don't really want to know. But we ended up splitting into 3 teams, each of them being highly encapsulated with minimal dependencies on other systems. And one thing that was really, really cool that we found that when we split up by domain was that we ended up also finding really cool boundaries of users, domain as well as tech stack. Because we're a machine learning company, a lot of our machine learning and data science code is obviously in Python, TensorFlow, PyTorch, whereas our applications are more written in JavaScript and Node.js. So literally I would be switching from JavaScript to Python on a day-to-day basis before we to this restructuring. And it also became much more of a mirror of the real world. Yeah, so just as a lesson, I think it's really important because like your teams are growing organically. You don't want to over-optimize before you've really understood the problem that your code is trying to solve, but it's recognizing when cognitive load has hit this critical mass, realizing that communication between teams should mimic the communication between your services, and also organizing teams by domain tends to be a pretty good idea. Yeah.
Thank you, Anne. So really, as this journey evolved, we want to take 3 lessons to give to you. The first one being use simpler solutions, so make your product code more flexible. A really great way of doing this is separating the orchestration from the execution responsibilities. Secondly, separating customer configuration from the product will allow you to be a lot more responsive to changing customer and product needs. And then thirdly, grouping teams by domain. This allows for fast engineers with less cognitive overload. So Tractable is a company that's been using deep learning in real life. We're a $1 billion valuation, we're a unicorn. We operate in 14 countries, which brings really interesting technological challenges. We've helped millions of people. And we've tapped into this $1 trillion industry. So if you're interested in anything that Wei Ann and I have been talking about, feel free to get in touch. Our details are here. You can chat to us later as well.
We do a lot of cool ML stuff that we don't have the expertise on, so we haven't touched on here.
Yeah. We can try and explain it badly. And check out our careers page if you find interested. Thank you very much.